Hello, in this video I'm going to talk about calculating bitwise shifts. This is beneficial for you if you're in year 9 and it's term 1 of understanding computers, and you also need to know this for GCSE computer science. Okay, so inside your computer there is a central processing unit. Whoops. And the CPU knows how to do things. It knows how to add and move data, but it doesn't often know how to multiply or divide. What it does instead is it shifts binary numbers using bitwise shifts, and this is a way it can double or halve a number. So I've got Python here on the left, and for this you need to understand why 55 shift left 1 gives you 110. Well, you can see what's happening here. The number 55 is being doubled once to get 110. So what does the processor do at that point? So first of all, it works out, well, it already knows the binary number 55, which is 18 and 5. So we'll agree that this is 55 in binary. And what's happening here is that the bits are getting shifted one place to the left. So if I add a 64s column, we can kind of see what's happening. All my bits got shifted to the left, and that made a space here. So now I've got a 0 in the ones column. And if you calculate this number, which is 64 plus 32 plus 8 plus 4 plus 2, the answer is 110. So this is an example of a bitwise shift left once. Let's try the other way. So this time let's do 77, and we're going to shift it to the right once. Shift right 1. The answer is 38, and the reason for this is, in this case, we've got the binary number 77, which is 64 plus 13. And in this case, we're shifting the bits to the right. So what happens now is this one bit gets lost, or the word is truncated, and the bits now all move down one place. So if we now calculate this number, you'll see that it's 32 plus 4 plus 1, plus 2 rather, plus 4 plus 2, which is where the answer 38 comes from. Let's do two more examples. This time I'm going to take the binary number 15, and I'm going to shift it left 3 places. Oops. Shift left 3. Let's see if you can already work out what the answer would be. What's happening here? Well, the CPU knows that the binary for 15 is 1111. So what's happening is the bits are now getting shifted not just one place to the left, but 3 places to the left. This means 3 extra zeros are added. So what's the new answer? In this case, it's 64 plus 32 plus 16, which gives us the answer of 96, 106, 112. Can you see why 15, 112, I've made a mistake, haven't I? 64 plus 32 plus 16 plus 8, of course, I missed off one of the bits. So we can see why the answer is 120. Another way of thinking this is, okay, 15 got doubled, it then got doubled again, it then got doubled again. So shifting to the left 3 times is equal to doubling a number 3 times. Let's do one more example. This time we're going to do 2049 shift right 3. Can you see why the answer would be 512? So it's not, when you're going the other way, it's not quite the same as halving a number, because we know that halving a number will give you a fractional value in some cases. But the way that Python works is it always is working with integers. So any fractional part just gets chopped off and we round down to the nearest integer. Let's do that in binary. A binary number requiring quite a lot of bits, but there are a lot of zeros. This is the binary representation, binary number 2049. What happened in this case is, I wrote shift right 3, but what we actually did was shift right 2. What should we do? Let's do shift right 2 instead. Can you see why it would be 512? So what's happening here is I'm shifting to the right. So first of all, this gets lost and this gets lost. All of the binary numbers then move down. It's tricky for me to line these up. So you can see why the result is 512. So what we've covered in this video is calculating bitwise shifts, shifting to the left to double a number, shifting to the right to halve a number.